right, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hopefully you guys are all well. Today we're going over the third quiz, the one you guys took yesterday. So let's actually just jump into it. Let me share my screen here. And let me make sure I can see the chat and all that good stuff. Okay, all right. So last time we were running through the quiz, we are running short on time, so I'm just actually going to jump into it. So forgive the abrupt start, but hopefully you guys are all well and you had a good long weekend and all that good stuff. Hopefully you guys took advantage of the break you had on Monday. Now it's time to get back to work. Before I start, I do want to remind you guys, just as an extra reminder, this is all in the quiz, in the syllabus and everything, but remember your first test is next week and it covers everything up to the lecture that you should be watching today. So the first test covers most of chapter 1 and that's on Monday. So pretty much it's going to be like a combination of all the quizzes that you've had up until this point. And so, yeah, you should be prepared for that. Maybe even watch a little bit ahead of quiz 12 if you want to get some of the ahead of lecture 12 if you want to get some of the bonus points in. But yeah, that just want to remind you of that. The test is going to be, and I'll send more information about this, but the test is going to be maybe an hour long, maybe a little bit more. But yeah, in terms of length, it's going to be similar to a quiz, except I'm going to ask less of the definition questions maybe, okay? But in terms of the questions you have to calculate or the conceptual questions, it's gonna be mostly that. So I'm not gonna ask you, okay, to add A over B plus or minus C over D, what is that? You know, like I'm not gonna ask you that anymore. I'm just going to assume you know that, and then I'm gonna actually test you on things. So just think of the quizzes without those types of questions and combine all the quizzes that you've had before, and that's pretty much what the test is going to be like. So if you've if you've taken all the quizzes and you've been successfully getting better at them, the test should not be a problem. So just I wanted to throw that out there. Okay, let's actually just jump into it now. So we are going over quiz 3, and the first 2 problems should be okay at this point. So let's actually do that. Yeah, so we've seen this so many times now. I'm gonna stop putting quizzes like so A over B plus C over D is that, right? You can cross multiply to get the numerators, and then you multiply the denominators to get the new denominators. Okay, so we all see that. The signs have to stay the same, so if it's a plus or minus, it has to remain a plus or minus, and so we have that. So that's nothing there. This one also shouldn't be bad. What is the LCD of the denominators?
It's none of the above.
Right, but what is the answer?
1 over 3x cubed.
1 over 3x cubed? No. What's the LCD?
Oh, x to the 7th. 1 over 3x to the 7th.
No. Someone tell me the LCD? What's the rule for creating the LCD?
Is it finding the greatest common factor of all 3?
Right. And in this case, that is?
Is it 1 over x to the 4th?
No. How do you create the greatest common factor? What is it? Well, it's not quite the greatest common factor. Like you don't need anything in common. So it's the product of all the factors that appear raised to the highest powers to which they appear. So 3x to the fourth would be the LCD. Yeah, you guys still need to look up LCD. I thought this was a throwaway question, but yeah. Okay, boom, boom. Let's move over. How do you combine these into a single expression? What did you do? Anyone?
I started by multiplying each of them by in order to get like the same denominator.
Okay.
So for the 3 over 2x, I multiplied that by 6, so I could get that all over 12x.
So you mean 6 over 6?
Yes.
Okay, and then the 1 over 3x?
I multiplied that by 4 over 4.
And the 4x?
3 over 3.
So that was 18 over 12x, and this is 4 over 12x, and this is 3 over 12x. And why 12x? Because notice that the denominators were 2x, 3x, and 2 squared x. And so the LCD is the product of all the factors that appear raised to the highest power to which they appear, which is 12x. So 12x is the LCD, that is the denominator that you want to create, and you multiply and divide by whatever you need to get that created. With that being said, now that everyone has the same denominator, you can just add the tops. So then you take 18 plus 4 plus 3, right? And so that would give you what? 25? That's the first one. Okay, so creating LCDs was important there as well, and we now know how to create them now. So what is combined to a single expression? What did you do here?
I multiplied the x minus 5 by x plus 7 and the x plus 2 by x plus 3 to get a common denominator.
Well, we could do that, and that's just by the rule in question 1. And so now we have the denominator here, x plus 3, x plus 7, that's going to be the common denominator. And then in the top, we can multiply out. So this is x squared plus 2x minus 35. And this is going to be minus x squared plus 5x plus 6, and that's all in parentheses. And we can see what cancels. So the x squared kills the x squared. I have 2x minus 5x. So that's going to give me minus 3x. And that takes care of those guys. And I have minus 35 minus 6. So that's going to give me minus 41. And normally we don't multiply out the denominators, but I just wanted to give you more practice on multiplying out. So this is x squared plus 10x plus 21. And so that leads us to, again, it looks like the first choice. Okay, question 5. How do you simplify rational expressions? Tell me the strategy here.
Don't you want to start by seeing if you can take out a common factor?
Right, but tell me what's your overall strategy? Why would you do that? What are you trying to do?
You're trying to simplify it, so you want to get like the lowest factor so you can cancel like the numerator and the denominator.
So the strategy is to factor both the numerator and denominator and cancel common factors. And the factoring part is what requires you to pull out the GCD in the first place. So the GCD, that's not the first thing that you would think about. You just want to know the overall strategy is I want to factor the top and the bottom and cancel common factors. Now, when you start worrying about, okay, how do I factor the top? How do I factor the bottom, right? And so individually, when you're thinking about factoring them, what do? Then there's a strategy for factoring itself. And the first step in the strategy is factoring out the GCD, okay? So we know the strategy is to factor the top and the bottom. So you look at the top, how do I factor that? So the first thing is I try to find a greatest common factor, which here it looks like there's a 2. And in the bottom, what does that factor as?
X minus 5, x minus 5.
Can I factor the top further?
Yes, because it's a difference of 2 squares. So it would be 2x minus 5, x plus 5.
All right. So these guys cancel. And we are left over with 2 times x plus 5 over x minus 5. And that looks like choice D. Okay. So simplify rational expressions by factoring and canceling. When it comes to factoring, the first thing you want to do is pull out GCDs. Then otherwise you go into the other strategies that I described in the lecture. Okay, dividing, how do we divide?
You take the reciprocal of the second fraction and you multiply, and then to do that, like you factor and then can cancel like terms, and then you can finally multiply across.
Multiply and we flip these guys. And now we factor. So the factoring of the first one, the top.
It would be x minus 4, x plus 4.
Bottom.
X plus 6, x minus 1. Yeah. No.
No.
X
no.
plus 3, x plus 3, x plus 2, sorry.
The top of this one.
x minus 4, x plus 2.
And the bottom?
X plus 4, x plus 1.
Okay, now what?
Now you could cancel like terms to simplify.
Okay, and who cancels here? So we have an x plus 2 that cancels. We have an x plus 4 that cancels. Is that it? That looks like it, right? So in the top now, I have an x minus 4 squared. And in the bottom, I have an x plus 3, x plus 1. Now in this problem, so that is just the straightforward strategy that we've gotten for how to compute things. But this problem also asks you to state restrictions in the variable. So it turns out like your x cannot be whatever it wants. There are certain things it cannot be. So, and that part was maybe a little tricky, but maybe you can tell me what is x not allowed to be here?
I think it's answer choice C, but I actually had a question about this.
Okay.
I was wondering, because it is more than -3 and -1, I was wondering like how we would get those additional numbers like -4 and 4, because
What makes you think it was more? Maybe I should start there. What makes you think it should be more than -3 and -1? Because my answer is right here. I see x plus 3, x plus 1 in the denominator. I know I can't divide by 0, so all I need to do is make sure that x is not -3 and -1. Why would you think there's more?
When I was taking the quiz, I actually put answer choice A. The only reason why I knew it was more is because I was reviewing the quiz and I saw the right answer, but I didn't understand like why it was more.
Okay, because you, right, so the answers become available after you take the quiz. Okay, so there is more to this. So this came up because of something I said in class, that simplifying does not actually fix the domain. So simplifying, you have to realize this is just us rewriting things to make it easier for us to do mathematical operations. However, you need to remember whatever is done, you need to make sure that it's cool with the original problem, right? So that's a very important thing. So this also came into play when we were checking equations, right? So when we tried to solve equation by squaring both sides or something like that, and we would get some answers, it was always important to, you know what, let's make sure these answers work in the original problem. Let's make sure they didn't allow a division by 0 in the original problem, etc. Right? Because if your x values could not work in the original, they're not allowed to work now. Just because you did your simplification and rewrote it in a nice form, the illegal x's will always remain illegal, right? So that's the important thing. So this is the important idea. So when it comes to talking about restrictions, this is very important. And this is something that, you know, it's bad. Like I have this joke in my head that just popped up now. I don't know why that's relevant. I don't even know if I should tell you guys, but whatever. This is one of those things where there are times when it's not a big mistake, it's not a big issue, but it is something that can cause you some headache if you don't pay attention to it in the future, in your future calculus classes, in your future math classes, etc. But it is an issue, although, you know, it's not going to pop up often enough for you to like worry about it, but you should worry about it. The domain has to work in the original problem. So even after you simplify, you have to realize that it doesn't fix things. And this is very, very important. When you do limits in Calc 1, this is actually going to come up. So it's a big deal, but in terms of how often it's going to cause you to get a problem wrong, it's not a big deal, but it's a big deal. So what you have to, the idea here, when it comes to the restrictions on the variables, for the restriction on the variables part, remember, simplifying does not fix domain issues, right? So that's something that you do want to keep in mind. I don't know why I'm putting it red. It's not like I don't want you to do that, but it's something that you should remember. It's actually important. X values that were not allowed before simplification are not allowed after. Okay, so for example, let's say I had, there was a 1 over x plus 1, and then I multiplied that by x plus 1 over x minus 2. Then here, notice that x equals minus 1 and x equals 2 not allowed, right? Because you would divide by 0. However, I could simplify this. And I could go and simplify by canceling the x plus 1s. And now the answer is going to be 1 over x minus 2. Now it's very important for you to realize x minus 1, x equals minus 1 and x equals 2 still not allowed. Right? In particular, students seem to always forget that you're still not allowed to plug in minus 1 in this scenario, because the problem you were given, you weren't allowed to plug in minus 1. So there's a gap at the position of minus 1 in the problem you were given. When you simplified, you're still not allowed to fill that gap. Like, how are you going to fill the gap? Like, you had that missing piece of information. Just because you rearranged it, it's kind of like you have like a mess on your floor and you just put a rug over it. Just because you don't see the mess anymore doesn't mean it's not there. You know what I mean? That's kind of what it's like. Simplifying is a way of cleaning up, but cleaning up by just making the thing that you don't want disappear, like you just put it out of view, which is essentially what simplification is doing. It doesn't actually fix the original problem. So that's actually important. The guys that couldn't work in the beginning are the same guys that cannot work in the end after the simplification. So that's very important. That being said, now let's go back to this problem. Can you tell me what were the restrictions in the very beginning? Like, what were the restrictions in the very, very beginning? So in the very beginning, I had 2 fractions, right? And I wanted to divide one by another. I know I'm not allowed to divide by 0, which means that this guy here is very important for me to pay attention to. I'm not allowed to plug in any x values that makes that guy 0. It's also true that this guy is something I need to pay attention to. I'm not allowed to plug in anything that would make that guy 0. There's one other place that I need to pay attention to. Does anyone see what that place is and why?
Could it be the numerator of the second fraction?
The numerator of the second fraction is something that is not allowed to be 0. Why?
Is it because we took the reciprocal, so it like used to be in the denominator?
Right, but even now you want to realize that it is in the denominator, right? So if I look at, maybe I should, so back to above problem. So it turns out in the original, you should know that I'm not allowed for this to be 0, it's not allowed for this to be 0, and it's not allowed for that to be 0. And why the third one, the last one that I circled, might have missed some of you, but you have to realize that what this is the following. It's like I had x squared minus 16 over x squared plus 5x plus 6 all over x squared plus 5x plus 4 over x squared minus 2x minus 8, right? So I'm taking one fraction and I'm dividing by another. Now, if I look in the denominator, what happens if the numerator of the fraction in the denominator is 0? Right? If the numerator of a fraction is 0, what is it simplified to? Right? The whole fraction becomes 0, right? So if you have 0 divided by anything, it's 0. As long as you're not dividing by another 0, of course, you understand, you can never divide by 0. It never makes sense. But if you have a fraction where the numerator is 0 and the denominator is something else, then that fraction is 0, right? So it turns out that the numerator of the guy in the denominator cannot be 0 either, because that would make that entire fraction 0, and then the whole division operation in the beginning, this division operation, would not work. So what you want to make sure is that this, and that cannot be 0.
Would that be true for any equation that looked like this?
Yeah, like you can never divide by 0. Anytime you're dividing by 0, it's bad, right? You have to avoid it all the time. And so the denominators of any fractions are bad, and anything that would make the overall denominator of the huge fraction 0, that's also bad. So there are 3 situations here. Now, when it came down to it, this part here factored into x plus 3, x plus 2. This part here factored into x plus 1, x plus 4. And this one factored into, what did we do here? X minus 4 and x plus 2, right? So if these guys are to be 0, then x is minus 3. This would mean x is minus 2. This would mean x is minus 1. This would mean x is minus 4. This would mean x is 4. This would mean x is minus 2. And none of these are allowed. Okay, so now hopefully you understand that we're not allowed to be minus 1, minus 2, minus 3, minus 4, or positive 4. And that leads us to choice C. So that's a very important point. And so whatever, after your simplification or whenever you're solving equations or whenever you're doing anything, the answer that you have, it has to make sense with the originally posed problem. You cannot give an answer where it's like, I didn't have that option in the beginning. How do I suddenly have that option? You know what I mean? Where are these? Domain, we've seen a bunch of problems like this, but knowing domains where your functions work, it's often going to be very important. So repetition is good. So again, we see here, you just look at, for the numerator, you need 3 minus x to be greater than or equal to 0. For denominator, X can be anything for the whole fraction. X cannot be 0. Okay, so if I look individually in the numerator and denominator, the numerator has a restriction. The denominator is x. X is a polynomial, has no restriction. However, because I put that in a whole fraction, so I'm looking at this whole thing, the x is in the denominator, which is not allowed to be 0. And so I have this number line. So this means that my x must be less than or equal to 3. So if I put in 3 here, x must be less than or equal to 3. And x is not allowed to be 0. So that's an open circle, going like that. And then now I find the overlap. Right, so I want to see where the two lines overlap. Notice that they overlap from -infinity all the way up to 0, but 0 I'm not allowed to touch because the denominator of the original fraction. And then everything up to and including 3 can work. And so that leaves us with, looks like the third option here. So I was nice here. I think all the rationalizing things that I gave you guys to do involved square roots, which I think was nice, but on the test I might not be so nice. So last class we did discover things like finding, rationalizing things that involved cube roots and things of that sort. So maybe on the test you can expect something like that. But here I just kept it simple. How do you rationalize things with square roots? People tend to know how to do that very well, just because of out of force of habit. But how would we rationalize the numerator in this expression?
Rad x minus rad a.
As in the first choice?
Wait, what?
That's, you said rad x minus rad a, as in the first choice?
Oh,
like
no,
there's some
no.
answer choices.
Oh, b.
Right, you have to divide by that as well. So you multiply and divide by the quote unquote conjugate. It's not okay to just multiply by it, right? You have to multiply and divide by it, right? So in the first choice, you just multiplied by it, but you also have to divide by it so you don't change the answer. And so, and the reason why that works is we can take advantage of the difference of squares in the numerator. And knowing the reason why that works is important. That's what's going to make you not get mixed up when if I threw in a cube root, for example. To just understand that I'm supposed to be taking advantage of one of the difference of cubes or the sum of cubes formula is going to let you know what you should be picking. Yeah, so here we have to rationalize the denominator. And the same principle that we did in the last one applies. So if I have rad 3 minus rad 6 over rad 3 plus rad 6, I need to multiply and divide by something. And it's going to be, and since the problem said rationalize the denominator specifically, you don't always have to rationalize the denominator, but this requested that you do that. There are situations in which you have to rationalize the numerator, and they show up fairly often. You'll see that in Calc 1 as well. So I'm going to focus on getting rid of the radicals in the denominator. So how I can do that is just change the middle sign. And not because change the middle sign is the important strategy all the time, it's because I'm changing the middle sign because I'm thinking of the difference of squares formula, where if I change the middle sign and multiply by it, then the result is going to be the squares of each of the terms. So the denominator is going to become radical 3 squared minus radical 6 squared, right? And that's why I changed the middle sign, because I'm thinking difference of squares formula, okay? Now the numerator is going to just become, well, radical 3 minus radical 6 times radical 3 minus radical 6. So this is going to be, well, radical 3 minus radical 6 squared. And in the denominator, I'm going to just have 3 minus 6. Okay, so now there are no radicals in the denominator. It is rationalized. So now I can simplify this a little bit. Did they expand the numerator? Yes, it seems like they did. So in the numerator, what is that? Is that just going to be radical 3 squared minus radical 6 squared? Yeah? Right?
No, you have to do
Right, no.
like
That is a
actually,
difference.
yeah.
That is distributing a power across a sum error. That does not happen. Remember, when you have a minus b all squared, it is a squared minus 2ab plus b squared. And that is what we're going to apply here. So I'm going to square the first one minus 2 times the first times the second plus the square of the last one. And that's what that should simplify into. So now that's 3 plus 6. That's this becomes 9 minus 2 radical 18 over 3 minus 6 is minus 3. So that's what it looks like. I checked my answers. Nothing actually looks like that. Well, so maybe I want to simplify a little bit. So what I can do here is notice that I can simplify this, this radical here. Radical 18, that's the same as 9 times 2. So this becomes 9 minus 2, radical 9, radical 2. This becomes 9 minus 2 times 3, radical 2. And I'm writing out a lot of steps here. You don't have to write out all these steps. I want everyone to see where my steps are coming from. And now what I can do is I can actually factor out a common 3 from the numerator. There'll be a 3 left in the 9, and there'll be a 2 rad 2. The 3's can cancel. And so what I have left is minus 3 minus 2 rad 2. Or minus 3 plus 2 rad 2. I don't remember what form the answer is in, but it should be one of these. And it looks like the second option. So you have to rationalize, which again, you multiply and divide by the thing that causes you to raise it to a convenient power. Whereas with the square root, the convenient power is squared. So I'm thinking of how do I get squares in here by multiplying and dividing by the same thing. Difference of squares formula can work. Afterwards, we end up in here as an initial answer. However, I do need to fully simplify. So it comes down to simplifying the radical. We learned how to do that. You pretty much break it into 2 parts where you put the factor that simplifies in the first radical, the factor that doesn't simplify in the second radical. And then after that, you just clean up. Okay, so all this was discussed in the last lecture. But now we're just kind of putting everything together. So all these things that I discussed, individually at least, I think they're all pretty straightforward. However, the trick is when you have a single problem that requires you to use all of these skills all at once, that's where things can get kind of tricky. And that's And again, that's why I go through Calc Chapter 1 very, very slowly, because really, as you're going to see, or hopefully you'll see, the more you see this, the better at math you're going to be, is that even the hard math problems, you know what, really, individually, the steps are very easy. Like I'm applying just some simple rule at any given time. There comes a point where that's no longer true in mathematics, but it's way up there. Like you're not going to be having troubles with mathematics when you're at that level. So yeah. But for now, all the elementary mathematics for the first 2 years of math classes that you're going to be doing, that's going to be true. Like a complicated problem is just a bunch of simple problems. If you understand the simple steps very, very well, then you will be fine. So right here, it looks like I'm doing a lot. However, there's a very simple steps. I am rationalizing by taking advantage of difference of squares formula. Everyone knows difference of squares formula. Then here, I'm simplifying by simplifying radicals, and we know how to do that. But knowing how to put this all together and when to do what, that's where the difference lies, right? And that's where strategies come in. So that's why I asked you earlier, okay, I want to simplify this fraction. What is the goal? What do I do? Okay, you need to factor the top and factor the bottom, right? And then cancel, right? Knowing the overall path to getting a problem solved is going to help you know, okay, I have all these individual skills. How do I put them together to solve this convoluted problem, right? The strategy is what helps you with that part. And then you keep breaking it down one by one. You take one chunk at a time. So when you said, okay, I have to factor the top and bottom, then individually, you know, okay, now let's focus on factoring the top. What is the strategy for factoring the top, right? And then you go into another strategy. And that tells you when to use each one of the skills you've learned, right? And you break it down like this, right? And it takes, and especially if you're not used to thinking of things that well, because I know a lot of students, they go to math class and they just kind of try to mimic whatever their teacher is doing on the board. And if the teacher does it often enough, you kind of just know how to do something automatically, but you never really understood what happened. And so there comes a point where you get to a math class where you actually have to understand what's happening, and then you get lost. So I see that happen to students all the time. They'd say things to me like, you know what, I was good at math right up until Calc 2, or I was good at math right up until this, or I was really good at math in high school, but then in college I'm really bad. I don't understand. And unfortunately, that's what happened. Like in high school, you were just going through the motions, not really knowing why. And then when there comes a math class where you have to actually know the why, because there's a bunch of different strategies that you can apply, and only a few of them are going to get you to the answer, but you don't know what to apply because you've never been in this situation often enough to know what to apply, right? So I go through chapter 1 very slowly and very carefully for that reason. I need you guys to understand each individual step. I need you to understand why each individual step is necessary. And if you're not used to thinking of math in terms of that way, I admit it will be annoying to force yourself to start thinking of that way. But again, it is very important that you learn to think of math in that way, because if you don't, the future holds a lot of trouble for you. And there's going to be a lot of frustration, because you're going to feel like you're working hard and you know what's going on, but you're not going to be doing well on the tests, and you're not going to be performing well. And you're just going to be like ripping your hair out. Like, I don't understand. My teacher just wants me to fail. And you're going to be reaching for all these reasons for why you're not performing well. And at the end of the day, it comes down to, no, you really just don't understand the simple steps well. That's where it comes from. And it builds and it snowballs to the point where, and it builds under the radar, because when you're in high school and you're kind of just going through the motions, you don't even realize that you don't know what's going on because you're getting all the right answers. And so you think like, yeah, I'm good at this. I know what's going on, right? Because in a lot of high schools, the only thing that matters is you got the right answer and your test scores are good, so everything is fine. Not really. That's not how it works. Like you don't know why these were good, you know? So if the reason is not good and valid and repeatable, it doesn't actually matter that you're getting the good results, because when you come into a situation where you don't have that handicap, you're no longer going to get the good results. And at that point, it's just going to be a lot of frustration and confusion and all that stuff. So I do encourage you guys to really think seriously about some of the things that I mentioned in class and about learning to think in this way. And just remember, yes, if you're not used to thinking in this way, it's going to be really annoying to start. However, just like in high school, when you just got used to going through the motions, eventually this kind of thinking will become like going through the motions. You'll just naturally be able to think about things logically and construct them in a way that, oh yeah, I need to make this step because of this reason, right? To just thinking that way, that knowing that I do this because of that, right? As opposed to, I do this because that's what my teacher did on the board and I just did it and I got the right answer, so that's cool. But understanding I did this because of this mathematically logical reason is a very different kind of thinking. And that's the kind of thinking that's going to help you in the long run. That's the kind of thinking that actually gets you educated, that actually means when you leave a class, you don't just, all the knowledge just goes out your head and you never remember anything after the class. The difference, what makes that the difference that you can move into another stage of life and you actually retain some of the hard work that you put in the previous stage of life, it comes down to really understanding how the pieces actually fit in. Okay, I went off on too long a rant there. We're only like halfway through the quiz, so let's actually just speed this up. So we want to get over ax plus b equals c. I spoke about this as a linear equation. It's really not something that people tend to have trouble in. Hopefully you realize that the correct thing to do was to first subtract the b, then divide by the a. So that's choice C. Find all solutions here. What were the solutions? Hello, this is you guys. I know I've been ranting for a while, but I do want you guys to still participate.
Would it be x equals 0 and x equals 1?
X equals 0 and 1. There's a very common mistake that happens here where students just do something like divide by x. It's particularly deadly when you have inequalities, but that's for another time. So common mistake.
I have a question.
Is to divide by x. And so you would get x equals 1, and that would be wrong. And the reason why it's wrong is because one of my screens went blank. Hello, just give me a check-in that you're still hearing me.
Yeah, we can still hear you.
Okay, because one of my screens went blank, so I don't know if I lost you guys or not. Okay. Okay, all right. So let me just make sure here. And you guys are still seeing my screen?
Yes.
Okay. And one of my laptop screens just aren't cooperating for some reason. I don't know why. Anyway, let's keep going. That being said, I told you guys what the mistake was. Let me tell you how to actually do it. So again, you should remember, we did this in class. The strategy is to, if it's not linear, bring everything to one side and factor. So you have x squared equals x. The next step is to bring everything to one side so that the other side is 0. You would factor, and then you would apply the 0 factor property. So this means that your x is 0 or your x is 1. Okay, so that's the correct way. The common mistake is actually just someone dividing through by x, and then they'd lose the 0 solution. This one was just me checking that you remember the quadratic formula. So this was also a giveaway problem. Do you remember the quadratic formula? It's minus b plus or minus the square root of b squared minus 4ac all over 2a, and that looks like the second choice. So nothing to actually talk about there. That's just, if you know it, you know it. I mean, you could derive it using completing the square. I did show you guys that, but I don't recommend that. That's the sort of thing you see once, maybe even try one time, but then you never do it again. There are a few things like that in math as well, where you just, one time you have to just derive something just to see why it works. But then after that, you just remember the fact and just run with it. So here we have one. Solve this equation for x. All right. And we are running low on time, but maybe I just want to get a little bit of input here. What did you guys do?
I started out by squaring both sides. And then,
nice. I would tend to agree. However, I would have done something first. You see, of course, we want to square both sides because of the radical. And I don't know why I wrote that so lean. We want to square both sides because of the radical. But at the end of the day, because there's a 1 on the same side as the radical, like I don't really want to actually get the 1 mixed up in all that, right? Like, so I would tend to, if it's possible to get only the radicals on one side, I would tend to want to do that. It makes your life a little bit easier because students expanding something like the square of that, especially if they're not really hot on the a minus b all squared formula, a lot of mistakes can happen there. They're less likely to make the mistake on the if they expand the square on the left side. So I would make this change, not because it's any more correct, but for psychological reasons. Students are less likely to make a mistake when squaring the 2x minus 1 than they are when squaring the 1 minus the radical of da-da-da, right? And this is just something that you would know just by keeping track of the statistics, right? So if you, when you're studying, you notice that when you start expanding squares where there are radicals in the thing and you keep getting it wrong, maybe just don't put yourself in that position in the first place, right? So yeah, squaring both sides can work, but I would rather just have the radical by itself on one side. That being said, the square of the first part and the square of the second part, now I just remove the radical, right? So you would end up with something like that. Now, I do want to show you that not doing this can actually just make your life a little bit harder. So if you had the 2x equals 1 minus the radical of 2 minus x, and you decided to immediately square both sides, what does the left side become?
4x squared.
4x squared. What does the right side become?
Would it be 1 squared minus, or no, it would be 1 plus 2x, 2 minus x.
No, that's distributing of powers across a sum error. A minus b all squared is a squared minus 2 times a times b plus b squared. Right? So you already see that there is the second way. It's not incorrect, but it's not as efficient. Right? You guys saw just now, like when I asked the question to the class, suddenly there was quietness. Like it's now something you have to think about and figure out. And it's super easy to make the mistake because the radical is there. It's like throwing people off. If you're not super good at the rules, you're going to mix up here. And now what you realize is you're going to have like a 3 minus x minus a 2 radical 2 minus x here. And there's another radical. Now I'm going to have to group everything and square again. You'd realize that if you don't isolate the radical first, it just makes your life a lot harder. It's definitely better to do it this way. Right? Now, will the student who's doing it the way that I started on the right eventually get the right answer? Yeah, if they're doing everything correctly. However, you're putting yourself in a situation where you're going to make more mistakes. Even if you're doing the right thing, it's just going to take longer to solve. Like, it's not worth it. You do want to isolate the radicals first. Okay, your life is much easier and you're less likely to make a mistake. So yeah, I would first move the 1, then square both sides, because then when the radical is by itself and I square it, I can just literally drop the radical. I don't have to worry about multiplying out and having an extra radical show up. Like after 1 round of squaring, I'm no radicals. Whereas on the right side, I have 2 rounds of squaring ahead of me, maybe even more if I don't do it. And at this point, you'll realize if I don't move the 3 and the minus x to the other side, I'm still going to get more radicals to contend with. So isolate the radical in the beginning. That would be the first step. Now we have this new equation. How do we deal with that new equation?
You bring the 2 minus x over to the other side to get the
Right.
equation equal
There's
to
a standard
0.
strategy for this situation. Bring everything to one side, make the other side 0. Clean up. So we have 4x squared minus 4x plus x is minus 3x. 1 minus 2 is minus 1. Now we want to factor. So maybe a 4. It has to be 1 here. So the middle term here is x. The outer terms, the multiplication is 4x. Can I get a minus 3x from this? Yes, if I make this a minus 4 and that a plus x, I can get the middle term. And so I would make sure this is a minus and a plus here. Then I set each equal to 0. So my x is either minus a quarter or x is 1. Then what I have to do is I have to check. Because whenever you're doing this squaring equation, you have to check. So if x is minus a quarter, and the original was 2x equals 1 minus the radical of 2 minus x. Yes. So I'm going to plug in a quarter here. That leaves me with a half on this side. Is that equal to this? So that becomes 2 plus a quarter. Oh, this leaves me with a minus a half on that side. And this guy would be here, 9 over 4, which is 3 over 2. And that's minus a half. So this one checks out. I would go and I would check now the 1, because that was the other one. So is my 2x equal to my 1 minus the radical of 2 minus x? Well, this side is just going to give me 2, whereas this side, if I plugged in x equals 1, would give me 1 minus radical 1, which is 0. So this does not check. So x equals 1 is not a proper solution. The only solution is this guy. And so that's that choice. Okay, let's speed up here. We had a lot of important lessons, so that's what drags these things on. I even had a little rant here. So this one was, it might not look like it, but it was a dead giveaway. Notice here, there's a negative sign. Absolute values are never negative. So this equation has no solution. Without actually doing anything. So this means no solution. Yeah, so that one wasn't even, it looked like a calculations question, but it wasn't. It was a conceptual question, actually. You would find that even if you went through the calculation route, at the end of the day, when you do the check, the answer that you found would not have worked. And then, but you would have wasted time. You could eventually get to the point that there are no solutions to this, but you would have ended up wasting your time. This one is possible though, because our absolute value is a positive 2. So let's actually figure this one out. We have x no, this screen is messing up. And give me a second. Okay, we're back online, it seems like. Let's continue. Yeah, these tablets really don't like Zoom. Streaming video really takes a hassle on their graphics processors, I think. Yeah, this one is not. Yeah, I think I'm gonna switch to something else. Just give me a second. Technology. Okay, hopefully now you guys are seeing the screen again. I'll leave my video off to make sure there are no more hiccups. You guys seeing the screen?
Yes.
Okay, all right. Let's just run through the rest of this pretty quick. Let's hope this thing works now. Okay, so here we have x plus 5 equals 2. What we would do is it breaks up into two equations. So if the inside is positive, the absolute value does nothing. If the inside is negative, the absolute value takes the negative of it. And so here I can have x equals -3. Here I would have minus x minus 5 equals 2. And so I would have my x equals -7. And both of those would work. You can check in the original. And so -3 and -7. Keep going. So we want to actually solve this equation. We know the strategy here to multiply the entire equation by the LCD. So I'm going to multiply this entire equation by actually a minus 6 times a plus 6. Why? That's the LCD. And hopefully we know how to find the LCD, although we did have some hiccups earlier. So this means I have the a over a squared minus 36. I'm going to multiply that by a minus 6, a plus 6. And then I have the plus 2 over a minus 6. And I'm going to multiply that by the a minus 6, a plus 6. Then I have equals 1 over a plus 6. And I'm going to multiply that by a minus 6, a plus 6. Now, of course, I don't have to actually multiply and divide because it's an equation. So I'm multiplying both sides by the same thing. This is allowed. This entire thing will cancel that entire thing. The x minus 6's will cancel here. The x plus 6's would cancel there. And you don't have to write out that step, but I just wanted to show you what it would look like. So now you end up with just an equation where there are no fractions anymore. So this is the power of multiplying by the LCD. Now we're just going to solve for a. It's now a linear equation. Get all a's to one side. That's going to be 2a on this side, and then move the 12 to the other side. That's going to be minus 18. So I'm going to get a equals minus 9. And this does check if I look at the original, right? I don't divide by 0 or anything. So minus 9. What was the mistake here? Well, I'll just tell you because we're short on time. It was, I want to actually change this to red. It was this point here. Because from that, this part means that x minus 1 equal to 0. So division by 0 occurred here. And so that is the error. The part where you divide by x minus 1 causes you to think that 1 is equal to 0 because you actually did a division by 0 mistake. So all of math breaks down. You can prove almost anything you want. Okay. This one, there are a couple ways to deal with this, but it is a regular calculus, a regular quadratic equation. Personal preference, I would multiply by 3 on both sides just to get things to look a little nicer. And then try to come up with two numbers that when I multiply them, I get 12, I add and get 6, can't factor. Right? I can't come up with any numbers like that. I don't know if you can, so I would just jump straight into the quadratic formula. Minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this leaves me with 6 plus or minus the square root of 36 minus 48 over 2. That you'll notice is negative. That means no real solutions. And how many real solutions does this have? 0. Another almost throwaway one, I think. So it's just checking whether you know all these rules. If you have a over a times b divided by a times c, you're allowed to cancel the a's, sure, because of course your a is non-zero, or the expression on the left wouldn't even make sense in the first place. The second one, a plus b over a, is not b. That's what someone canceling across sum might think that. The third one, also not true. That's distributing powers across sums. This one is true. Multiply and divide by x to the third. Essentially, this is someone rationalizing the denominator. This one, not true. You cannot split a fraction across the denominator. Also, when you try to add these, it's not true. It's just not. Based on the rules that we've seen. Last question. It was a compound fractions question. And I'll actually run through the bonuses. It's not going to put us too, I mean, we're already over time, but I think they were short. How do you go about simplifying this? Well, the quickest way to simplify a compound fraction, as we know, is to multiply and divide by the LCD, which in this case is x plus 1. X plus 1 is the LCD. This gives us, in the first case, the x plus 1 cancels. Then I would have that. In the second one, x plus 1 times 1, then the x plus 1 would cancel, and I would have that. So it's 1 minus x minus 1 over x plus 2. And this is just minus x over x plus 2. And that's that one. So yeah. So each of these, there were no problems that I think should take you a long time. It's just that me elaborating on everything, why it was the right thing to do, took a long time. The rant and technology issues didn't actually help. This is just, again, something that you should just know based on the lectures. The center in this situation is going to be the negative of the guy beside the x, comma, the negative of the guy besides the y, and this part here is 5 squared, which is r squared, the radius squared. So that leaves us with this choice here. That's just something you'd know if you knew the equation of a circle, which if you watched ahead, you would. Or maybe even you might remember that from high school. This one. Okay, so this one's a little bit more involved, but not by much. So the thing would be to remove the 3, divide by the 2. And then we know that if you have something in absolute value is less than something, you can actually put that thing on both sides, where the negative goes on the other side. Then I can add 5 to both sides. So it's somewhere between minus 20 and 30. So that's that one. And I think that's the whole quiz. All right, so as always, I will post the, hold on a second. Yeah, as always, I'll post the PDF of everything I did along with the video, and you guys can review that. Hopefully you understand everything that went on in the quiz. As Charlotte pointed out, you guys already have the answers, so you can look over those, but hopefully now you understand more of why those were the answers. We'll wrap up there. We're 4 minutes over schedule, but overall, I think there were some good lessons in this lecture. Hopefully you take them to heart and go forth and be successful. I also do remember that someone asked me for an office hours via email, so I'll send you guys the link to the office hour room right now, so you can look out for that. As for the rest of you, have a good day. Watch lecture 12 today. Your first test is next week.
Perfect.
Yes.
So we're supposed to be up to lecture 12, and that corresponds with which web assigns, like 1.8 and 1.9?
I believe so, yeah.
So
it's around there. It's like 1.9, maybe 1.10, but I don't remember. But definitely up to 1.9 for sure.
Because on WebAssign, it has up to homework 3.2 due this Monday. So
Okay.
It makes
Yeah, I'll move those.
Okay.
You can send me an email reminder, but I'll move those. So
Okay.
the first test is pretty much chapter 1.
Okay, got it. Thank you.
Okay. All right. As for that, any of you have any other questions, you can email me. But for now, we'll end there. Sylvester gave me the thumbs up. All right. I will see you guys in the next one.